All right, guys, so we're going to go on and start looking over the review sheet. For problems 1 through 6, find the value of x and state if it's a Pythagorean triple. Now, Pythagorean theorem is what we use to find the missing sides of a right triangle. A squared plus b squared is equal to c squared. So for this first one here, they give us the values of a and b, the two sides, and we want to find the hypotenuse. So here we would do 3 squared plus 4 squared is equal to the hypotenuse squared. Now since 3 and 4, both of the side lengths on this side are both numbers, we could just plug this into the calculator. Because we can say 3 squared plus 4 squared is 25. So 25 is equal to x squared. At this point, we would square root both sides, and the square root of 25 is 5. So for this problem here, the hypotenuse, x, is 5. Now we consider a Pythagorean triple if all three side lengths are integers. Do not have a decimal, and since this is 5, this would be yes, this is a Pythagorean triple.
So no matter what, if it's a full integer, it is a Pythagorean triple.
If it's a decimal, it is not. Any other questions on 1 or 2? Or any questions on 1 and 2? The instructions? Any questions on 1 and 2? All right, we're looking at 3 and 4. So we look at these here. These are similar to 1 and 2, but this time we're not trying to find the hypotenuse. We're trying to find one of the two sides. And again, we're still using the Pythagorean theorem. A squared plus b squared is equal to c squared. Now this time they told us the hypotenuse is 17. One of the side lengths is 8. We need to find the other one. Now this case here, since the two numbers that are given aren't on the same side, we do need to calculate these individually. So the first one we can do is 8 squared. And if we plug 8 squared to the calculator, we get 64. Now we do also need to plug in 17 squared, which is 289. At this point here, we do need to get x by itself. So we would subtract 64 from both sides. And when we subtract 64 from both sides, we do get x squared by itself. But we need to do 289 minus 64, which is 225. And again, at this point, we need to take the square root of both sides. Square root of x squared is x. Now we take the square root of 225, which is 15. So the other side of the triangle is 15, and is this Pythagorean triple? Yes, because we got 3 whole number answers. Yes. Yep. Any other questions on 3 or 4? Questions on 5 or 6? Seven through 20. Determine if the following triangles are right triangles. Now, a triangle is considered to be a right triangle if a squared plus b squared is equal to c squared. Because the only way we can use the Pythagorean theorem is if it is a right triangle. So for this one here, for number 7, we can just plug the numbers into the Pythagorean theorem. Which side length is going to be the hypotenuse? 29. Hypotenuse is always the biggest side, which means 20 and 21 are the two other sides. Now at this point here, we could plug everything into the calculator. We can do 20 squared plus 21 squared, which is 841. And then the other side, we can do 29 squared, which is, are these the same? So is it a right triangle? Yes. It is a right triangle. Because if they're equal, then it is a right triangle. If they're not, then it is not. Yes, because the hypotenuse is our C value, and the hypotenuse, by definition, is the biggest side. So if we looked at 8, 11, 60, and 62, 62 is our hypotenuse. So if we plugged into the formula, we'd have 11 squared plus 60 squared is equal to 62 squared. Now on the calculator, we can do 11 squared plus 60. We can put parentheses around it. Since it's positive, we don't necessarily need the parentheses, but we can put them anyways. We get 3,760, 3,721. 700. Now we can also do 62 squared, which is 3,844. So this is not right. Now, if C is bigger, it's obtuse. If C is smaller, it is acute. So this would be an obtuse triangle. Determine if the following triangles are right triangles. Any other questions on 7 or 8? You ready to move on? Yes. Questions on 12 through 17. Determine if the following side lengths the acute of the triangle make it be an acute right obtuse. It's acute if a squared plus b squared is greater than c squared. It's right if a squared plus b squared equals c squared, and it's obtuse if a squared plus b squared is less than c squared. And we can pick any of these here and plug it in. So for 12, we can say 60 squared plus 91 squared and see how it compares to 109 squared. So 60 squared plus 91 squared. 60 squared plus 91 squared is 11,881. Now we need to see what 109 squared is. Now for these here it doesn't, mainly because the numbers are positive. If they were negative and we squared them, we would need the parentheses. Because a negative times a negative is a positive, and if you don't put the parentheses around it, it'll just square the number and then attach the negative afterwards. Now these here are equal, so this is right. Now for 13, 7 squared plus 8 squared compared to 9 squared. Well, 7 squared is 49. 8 squared is 64. And 9 squared is 81. 64 and 49 would be 113, which is greater. So this is a cube. And we would do a similar thing with 14, but we'd be plugging in 15, 112, and 140. Are there any other questions on these here? Do we feel comfortable with acute right obtuse? Now we can't say much for the angles without using our inverse trig, but we are able to find these here. Any other questions on these here? We good with these here? Find the two missing sides for each special right triangle. Now, our special right triangles came into different setups. Yes? Because we had the 45, 45, 90. And we had the 30, 60, 90. Because we worked with these here last week, this week. 45, 45, 90. In this here, we know that the two sides opposite the 45 are the same. And the hypotenuse is whatever that side length is times the square root of 2. So if we're given the hypotenuse in a 45, 45, 90, to get back to the legs, we divide it by what? We divide it by the square root of 2. If we have the legs length to get to the hypotenuse, we multiply by square root of 2. 2. So here, for 18, since this one angle is 45, the other has to be. So the sides opposite the 45 are the same. So x is square root of 3. And the hypotenuse is whatever that length is times the square root of 2. So the hypotenuse would be 7 square root of 3 times the square root of 2. In the calculator, we can do second square root of 3 times second square root of 2, which is so the hypotenuse in this case is 7 square root of 6. Any other questions on 18? Because in a 45, 45, 90, if we're given one of the legs, the other leg is the same, and the hypotenuse of whatever that length is times the square root of 2. Now at number 19, it's another 45, 45, 90. What do we know about x and y? They're going to be the same. And the hypotenuse is whatever the length of the leg is times square root of 2. But since we're given the hypotenuse, to go back to the legs, we do what? By the square root of 2. So we're taking this length and dividing it by the square root of 2. So we can say 6 second square root of 2 over the square root of 2, which is, so x is 6 and in a 45, 45, 90, the legs are the same, and the hypotenuse is whatever that length is times square root of 2. If we're given the hypotenuse, we divide it by the square root of 2 to get the other two sides. Questions on 18 or 19? Now 21 is the same thing. X and y are going to be the same. Now they gave us the hypotenuse, which is 4. And to get back to the legs, we take the hypotenuse's length and divide it by square root of 2. So this time in the calculator, we can do 4 over the square root of 2, which is 2 square root of 2. So the value of x is 2 square root of 2. The value of y is 2 square root of 2. And that is it. Any questions on these here with 45, 45, 90? Yes.
Do you draw like the triangle again where it has like the, yeah. Can I talk about that?
Yeah. Okay. As long as you understand how to go from one to the other, that's the key. Because if we're given the legs to go to the hypotenuse, we multiply by the square root of 2. If we're given the hypotenuse, we divide by the square root of 2. Now, 30, 60, 90, everything really revolves around the short side, the side opposite 30 degrees. Because if we're given the side opposite 30 degrees, the hypotenuse, the side opposite 90, is twice that amount, twice the amount. The short side times 2. The side opposite 60 is whatever the short side's length is times square root of 3. So if we're given the short side, we multiply it by 2 to get to the hypotenuse, multiply it by the square root of 3 to get to the side opposite 60. Multiply by 2. Multiply by the square root of 3. However, if we're given the side opposite 60, to get back to the short side, we divide by the square root of 3. Then to get to the hypotenuse, we multiply that length by 2. And if we're given the hypotenuse, to get back to the short side, we So if we're given the side opposite 30, short side, we multiply by 2 to get to the hypotenuse. We multiply by the square root of 3 to get to the side opposite 60. If we look at this here, what side are we given? The opposite of 30, we give her the short side. So to go from the short side to the hypotenuse, because y is opposite 90, we do what? Times it by 2. So y is 10. If we go from the short side to the hypotenuse, we multiply by 2. If we go from the short side to the side opposite 60, we're multiplying by. And 5 times the square root of 3 is 5 square root of. So x is 5 square root of 3. And that's it. Any questions on number 20? If we look at 22, we're given 14. 14 is what? Hypotenuse. So we want to go back to the side opposite 30 first. So if we went from the short side to the hypotenuse, we multiplied by 2. So to go back, we would take 14 and divide it by 2. And 14 divided by 2 is? So the value of y is 7. Now we need to go from the short side to the side opposite 60. Yep. Which is? So x is 7 square root of 3. Because that's all we're doing. We're going back to the short side and then going from there. Y is 7, x is 7 square root of 3. Now the last one of these special rights that we have on the review, we're given 6, which is opposite the 60. Yes. To get x, we're taking 6 and dividing it by the square root of 3. We can do this in a calculator. We can say 6 over the square root of 3, which is 2 square root of 3. So the value of x is 2 square root of 3. So 2 square root of 3 times 2 in the calculator, we can say times 2, which is 4. So y is 4 square root of 3.
Look at this hard work.
But there's not a whole lot to it. With 45, 45, 90, we're either multiplying by the square root of 2 or dividing by the square root of 2. With the 30, 60, 90, if we're given the short side, we multiply by 2, multiply by the square root of 3, we're done. If we're given the hypotenuse, like here, we divide it by 2, and then multiply that number by the square root of 3. We have it. If we're given the side opposite 60, we divide it by the square root of 3, and then multiplied it by 2. Those are the main operations we're doing with any of these here. Any other questions on the special rights? Do we feel good with these here? Because they work this way every single time. They have a special arrangement for their sides. Yeah, this is going to be 4 and 8. And this here is going to be 14 square root of 2, and this is 7 square root of 6. Because we're still using the properties of multiplying by 2 and the square root of 3 to get there. Because 4 square root of 3 divided by the square root of 3 is 4, and 4 times 2 is 8. 7 square root of 2 times 2, because this short side is 14 square root of 2, and 7 square root of 2 times the square root of 3 is 7 square root of 6. Questions on any of this here? And again, on the test, do make sure which sides are opposite 30 and 60. Don't just assume, just based off of how it's set up, which angle is which. So if we feel comfortable with these here, we'll move on to 28 through 29. Find sine, cosine, and tangent as fractions of each acute angle. 28 or 29, pick one. 28. So we can do sine of angle A. Now the hypotenuse is 97. Now sine, if y'all want to write this down, of an angle is opposite over the hypotenuse. Cosine of an angle is adjacent over the hypotenuse, and tangent of a given angle is opposite over adjacent. So now A, the opposite side to angle A is 65. The hypotenuse is 97. Now it doesn't ask for us to write it as a decimal, it just wants it as a fraction, and this is it. Now cosine of A. Adjacent would be 72 over, and tangent of A, opposite 65 over 72. Now, sine of angle C, the opposite side to angle C is 72, but the hypotenuse is still 97. Cosine of C, adjacent to angle C is 65 over 97. And lastly, tangent is going to be 72 over 65. Hopefully these here, setting these up as fractions, aren't too bad. They're kind of nice. But do pay attention on the test that for some reason, because I do provide sine, cosine, tangent. I do provide these already. You just have to fill in the blank. Just make sure you do attach the correct one with the correct sine, cosine, or tangent. I may or may not do sine, cosine, tangent on the first one and then do cosine, sine, tangent on the second. So do pay attention, because if that does happen, You might have them flipped. Questions on 28 or 29? $30 through 35. I hope all of you get these right. Yes. Tangent of 49.8 is 1.1833. You just have to plug these into the calculator. Cosine of 89.2 is 0.0139. I will take this, or I will take 0.0140, because the number after 9 was a 6, which means we round up, which makes the 9 go to 10, which makes us 40. I will take either. Questions on these here? And again, we went over this sine, cosine. The values will never be greater than 1 or less than -1. A tangent can. Tangent can be bigger than 1. Just give me 4 decimal places. Questions on this here? Rewrite sine as cosine and cosine as sine. Well, we know that sine of a given angle is equal to cosine of 90 minus that angle. And cosine of a given angle is equal to sine of 90 minus said angle. Which means on all of these here, to rewrite sine as cosine, I'm taking 90 and subtracting from it 67, and 90 minus 67 is 23. So cosine of 23 is the same as sine of 67. Here, it's supposed to be a parentheses. I started writing an E because sine is an S-I-N-E, but the function itself is S-I-N. Now don't put, again, I am going to count a point off or part of a point off if you write this as cosine equals 23. It's cosine is not equal to 23. It's cosine of the angle. It's in parentheses. So this here is not correct. Because for sine of 2, we'd have cosine of, well, we would do 90 minus 2, which is, so this here would be cosine of 88. The same thing's true with cosine. To rewrite it as sine, we take 90 minus our angle, 3.2. So we have 0.8, which would make it 4. So sine of 86.8. That's it. Questions on any of this here? We good with this here? Incidentally, what would sine of 45 be as cosine? Because again, opposite over adjacent, they actually give us the same value. What's sine inverse of sine of 81? Because again, sine inverse and sine cancel each other out. And for all the ones we will work with, they will. Cosine inverse of cosine of 8.7 is, and again, if you're not sure, we can do cosine inverse of cosine of 8.7 and get, yep, and if you don't think like it is, so 191 over 100, tangent inverse of tangent of over you can type it in the calculator and the calculator will do it for you. So it's not necessary. The only times it does give us something different is if the angle is greater than 90 for sine or less than negative 90, or for cosine it's greater than 180 or less than 0. Then the numbers change a little bit. Now, let's look at 45 through 50. Again, to find the angle, we're using our inverse trig functions. So sine of angle A is equal to 0.743. We would apply sine inverse to both sides, as these will cancel, leaving us with A is equal to our given angle. We're just applying sine inverse to both sides. Well, at this point, we can plug this here into the calculator. 0.7436, which is 48.04. Yeah, so we can say 48.04, 48.038. Any of those work. Give me at least two if you're not sure. If you're not sure if 2 decimal places is far enough, give me as many as you want. Questions on number 45? 46, what would we use? Cosine inverse. And the reason we're using cosine inverse is because we don't have sine anymore, we have cosine. So those will cancel out, giving us A is equal to cosine inverse of 0.3496. And again, in the calculator, we can say second cosine inverse of 0.3496, which is 69.53. 69.53, we could say 0.54 because the number after the 3 was 7. I will take either one. Again, I'm not going to make you guys round up, round down, because again, it didn't specify where we needed to round to. So I will take either one.
So the tangents.
Yep, tangent would be the same thing. If you will watch the video later, it's going to be posted tonight. Yep. Because for tangent, we would do the exact same thing, just using tangent inverse. So like 50, again, we're applying tangent inverse to both sides, telling us A is equal to tangent inverse of.
So it's just the inverse of the circumference that we have.
Yes. So second tangent inverse of second square root 3 is 60. Now, not every angle is going to be an ugly decimal, because there are some that work out to be a nice measure. Any other questions for these here? 51 through 52. Find the missing side. Now with these here, we're using sine, cosine, tangent. Essentially, we're doing what we just did, but we have to set it up. And depending on what side we are given and what side we're looking for will depend on if we use sine, cosine, or tangent. Now, if we look at 51, the angle that we're given is 36. The side that we are given is 27. Is it opposite, adjacent, or the hypotenuse to our angle? 27 is opposite what? The right angle. So this is hypotenuse. If we're given the hypotenuse, tangent doesn't work. Tangent's what? Opposite over adjacent. We need one with the hypotenuse, so we're looking at sine or. Now, This, and x, is it opposite or adjacent the angle? So which one uses adjacent and hypotenuse? So cosine of what? Cosine of the angle, cosine of 36 is adjacent over the hypotenuse. Because if we're given the opposite side and the hypotenuse of a given angle, we use sine. If we're given opposite and adjacent of our angle, we use tangent. Yes. And when we solve this here, the first step's always going to be the same. We're going to multiply by the bottom of the fraction when we're solving for a missing side, because these two will cancel out, telling us that 27 times cosine of 36 is equal to x. Once we multiply both sides by the bottom of the fraction, you do need to ask yourself, is the variable by itself? Yeah, x is by itself, yes? Which means we can throw this in the calculator. 27 cosine of 36 is, round your answer. Normally we'll go to the nearest tenth, 8.4. If you're not sure, you can ask and I will specify. Or if you want to just give me several decimal places, I will take it either way. Because 21.84, I will take. At least give me 1 or 2 decimal places. If you give me 27, that's nowhere near it. That's going to be wrong. Any questions on this here? And I will say with these here, please set it up. Don't just give me an answer. Because if you do give me the correct answer, awesome, you will get all points. If you just give me the answer and it's wrong, you will lose all points. Because there are points attached to setting it up correctly and using the correct trig function. Setting it up, cosine of 36 equals x over 27. I do give points for setting it up correctly. So using the correct cosine in this here, because if you use sine for this, set up this way, you would get it wrong because sine has a different value for 36. Does that make sense? So I do give points for setting it up correctly. If you do feel confident that you have it set up correctly and solved correctly, you can just put the answer. But if you get it wrong, you lose the points for setting it up. Does that make sense? Questions on 52? Let's look at 53. So they gave us a side, one side that is 12, is it? It's the hypotenuse, opposite 90, yes? So that means we're using sine or cosine. Now, 14 is our angle. X, the side we're looking for, is opposite, so we have to use sine. So sine of 14 is equal to the opposite side length over 12. Our first step here is 2. Multiply both sides by 12, telling us x is equal to 12. Yes. 2.903, 2.9. I will take either 2.9, 2.903. I will take either of those. Any questions on these here? Now, if x was not by itself, the variable is not by itself after our first step, we would have to divide by the trig function. Yes. It's all based off what's given. So if we look at 54, so we have the angle 56, yes? Well, the side that's not given to us is the hypotenuse, yes? If we're not looking for it and it's not given, I'm not worried about it. So all we're left with is the opposite side and the adjacent, yes? Well, sine is opposite over hypotenuse. We do have the opposite side, don't have the hypotenuse, so I'm not using sine. Cosine is adjacent over hypotenuse. Still, don't have hypotenuse, so we're not going to use cosine, which leaves us with tangent of 56 is opposite over the adjacent sides. Because on the previous one, we were given the opposite side and hypotenuse. Opposite over hypotenuse, the one that uses both, is sine. If we're given adjacent and hypotenuse, we use cosine. Essentially, we're picking which one will give us two pieces of information, the angle and one of the two sides, and we can solve for the other. Now this here, we would multiply both sides by 14, telling us 14. Tangent of 56 is and if we plug it in, I believe we do get 20.7. And that's it. Questions on any of this here? Do we feel pretty comfortable with these now? Yeah. And again, if you're not sure, especially on setup or plugging it in, set it up first. Yeah, if you're not comfortable or just not sure you did the calculations right, set it up. Write the steps out. Because I can help you, I can give you points with that setup and work that way. But if you just give me the answer, I only have so much to work with. And I believe 57 through 60 are the last problems on the review sheet, yes? Now with this here, again, finding the third side of the triangle is going to make these easier to work. A squared plus B squared equals C squared. Doesn't matter which one we pick, we can pick 15. A and B are 15 and 20. In the calculator, we can say 15 squared plus 20 squared is. So what we're doing here is just the same as what we did at the beginning. So x, we found is 25, yes? Or well, really should be z. This variable here is 25. I really need to go back and fix that so it's not the same. But what else are we looking for? We're looking for the two acute angles, x and y. We're looking for these here. Now, these here, to find them, we're going to do exactly what we did earlier, kind of with doing the inverse trig functions. Now, again, with this here, if you let me, yeah, it's just setting them up and solving. So for this here, we can use whatever one we want. Sine of x is opposite over hypotenuse. We'll finish this up. I will do one of these tomorrow in class before we take the test, and then I'm going to give you the test. Test is going to be 2 days anyways. Now with this here, again, everybody's left already, but with this here, we are just setting it up, and it doesn't matter which one we use, because since we're given all three sides, we just have to pick one. And we apply the sine inverse function to both, telling us that angle x is equal to sine inverse of 20 over 25, which we can plug in the calculator. Is 53.13. And again, these two angles. Now to find the other angle, there's different ways we can go about it. One of them is, let's go back up. Now we could use sine, cosine, or tangent. This time I could just say cosine of y is equal to the adjacent side over the hypotenuse. We would apply cosine inverse to both sides, leaving us with angle y by itself is equal to cosine inverse of 20 over 25. Calculator, second cosine inverse of 20 over 25, which is 36.87. 7. We also have that these two acute angles will add together to be 90, or all three add together to be 180. So what we could have done instead is, it's a different color, is taken 90 and 53.13 and added them together, which would have given us 143.13. Now, since all three angles add together to be 180, we can subtract it from 180, 7, 8, 6, which is actually what we found as the other angle. So for these here, we're trying to find the two missing angles. And that's it.